We are doing exercise 4.6 in this video. This video is about finding the solution of a system of linear equations using determinants. So watch this video carefully. This exercise is very important if we talk about CBSE exams. So let us begin. First of all, question number 1. Examine the consistency of the system of equations. This word consistency, you must have already heard it in class 10th. Two lines are called consistent if it is possible to find the value of xy from those two lines. And graphically, consistency means that those two lines either are coincident or either they are intersecting each other at a point. Inconsistency means that the lines are parallel. If it is a two-dimensional plane, it means that the lines are parallel. Okay, so this consistency we have to check. Now what is the method of finding the consistency? Now I'll simply tell you the algorithm with the help of these examples. So first of all, you make a matrix with the coefficients of x and y. 1, 2, 2, 3. Matrix with the coefficient of x and y. Then you make a matrix X, we call it as variable matrix, and in the column we'll write these variables x and y. Okay. Then third matrix that you have to make is matrix B, in which you'll put the value of these constants which are at the RHS of the equations, in this case 2, 3. So this is always the first step to check the consistency of a system of linear equation. Now next thing that you can notice is that when we multiply a with x, it is equal to b. And why I'm saying so? Now if you multiply a with x, what you'll get? 1x plus 2y, isn't it? So you'll get 1x plus 2y, 1x plus 2y. And similarly for the second row, you'll get 2x plus 3y, 2x plus 3y. And this is how we can say that x plus 2y, according to the question it is 2, so this is 2, and 2x plus 3y, this is 3, so this matrix is 2, 3, which is B, so AX is equal to B. I hope you understand this fact. Okay, so AX is equal to B. I have proved it for you. Now, how to use this information to check the consistency of the equation? Now, since AX is equal to B, it means if I pre-multiply this equation with A inverse, what I'll get? A inverse into A will be I, identity matrix, and identity matrix into X will be equal to X. And at the RHS, A inverse into B will get A inverse into B. Okay. Right. A inverse into B. So to find X, that is the value of X and Y, we need to multiply A inverse with B. Okay. So B, we already know what it is. Now the problem is with A inverse. Now what is A inverse? A inverse is 1 upon determinant A, 1 upon determinant A into adjoint A. We have already learned this fact, this formula in the previous video. A inverse is 1 by determinant A into adjoint A. So see, if determinant A is 0, that is, if a matrix is singular, determinant A 0 means matrix is singular. If the matrix is singular, then we can't find A inverse, and this will create problems. If determinant A is not 0, then finding A inverse is possible, and then in that case finding the value of x is also possible, right? So simply what I have explained you, if determinant A is not 0, that is the matrix is non-singular, then A inverse can be computed easily, and then that A inverse into B will give you the values of x and y, and hence the equation will be consistent. That is okay. So for example, in this question, if we find the determinant is 3 minus 4, that is minus 1, determinant A is not equal to 0, that is matrix is non-singular. So since it is not equal to 0, it means A inverse can be computed, and hence the value of x can be computed, right? So these equations are consistent. The set of equations is consistent. Okay. So in an example, I'll show you the cases where determinant A is 0. Then what we have to do, that I'll discuss. So currently, you know, if determinant A is not 0, then the system of linear equation is consistent. Similarly, in this question, you see, if I make a matrix with these elements 2 minus 1 1 1, right, a variable matrix xy, and then constant matrix 5 4, and if I calculate the determinant, it is 2 plus 1 3. Therefore this is also consistent without any problem. Third question, yeah, now this question, in this question I'll explain you what to do when determinant is 0. So same procedure we have followed, that is first of all we made 3 matrices. First one is 1 3 2 6 with the coefficients, then variable matrix, and then the matrix formed by these constants. Okay, and then I followed the formula, that is Ax is equal to B, and then finding the determinant, I found that determinant is 0. So on finding that determinant is 0, we can't directly say that it is inconsistent, because in A there is one possibility of being consistent, right? So what we'll do, after determinant A is 0, we'll find adjoint A. And how to find adjoint A? Already in last video I've taught you, change their positions and change the sign of these two elements. So in this main primary diagonal, change the position of these elements, and in the secondary diagonal, this diagonal, change the sign, and you'll get the adjoint, right? So adjoint A into B you find. So adjoint A into B, if you find, it is 30 minus 24, that is 6, and then minus 10 plus 8, that is minus 2. Adjoint A into B, if it is not a 0 matrix, then in that case the given system of linear equation is inconsistent. But let us say if adjoint A into B is also a 0 matrix, then we'll say that the system of linear equation is consistent with infinite solutions. With infinite solution. Now that is out of the scope of this book, but I'm repeating myself. If determinant A is 0 and adjoint A into B is a 0 matrix, in that case the system linear equation is consistent and it has infinite solutions, right? That is, the lines are coincident. I hope you got my point. So generally, if in this exercise, what you'll get, if determinant A is 0, then adjoint A into B will be a non-zero matrix, and hence always you'll see that the system of linear equation is inconsistent. That you'll see in this exercise. Now this is a 3 by 3 system, right? 3 by 3 system, and we have to check its consistency. So again, same thing, A, X, B. Now everything has been scaled up. This matrix X is now XYZ because 3 variables are there, and this matrix B we have 1 2 3 1 2 4. And now I'll just check the determinant. The determinant checked for this is, first of all write this one, then change the sign minus 1, then this one. Now hiding this one by column and row, I'll get 6A minus 2A, that is 4A. Hiding this one by column and row, we'll get 4A minus 2A, that is 2A. And hiding this 1 by row and column is 2A minus 3A, that is minus A, right? And finally we got A not equal to 0. Since it is not equal to 0, the matrix is non-singular, therefore A inverse exists, and therefore the system of linear equations is consistent, right? Again, examine the consistency, and this time again the same procedure will follow. Matrix A, 3 minus 1 minus 2, Now x is not there, so 0, 2, minus 1. In this case, z is not there, so 3, minus 5, 0. And then variables x, y, z, and the matrix B, 2, minus 1, 3. Okay. And now ax is equal to b, as we already know, capital X we have to use. Right. Now to check the consistency, determinant we'll find, and by column I will solve because there is 1, 0, it will be easier. So 3 minus 0 plus 3. Now hiding this 3 by column and row, we'll get 0 minus 5, that is minus 5. For 0 I am not doing any calculations, and for this 3 hiding by row and column, we'll get 1 plus 4. 5 3 is 15, minus 15, this is 0. So now what we need to check is adjoint A into B. If adjoint A into B is 0, then it is consistent, otherwise it is inconsistent. So we have found adjoint A. How to find? First of all, we need to find all the cofactors, then transpose, and then you'll get your adjoint. I'm not doing this calculation here. And then adjoint A into B, when you find minus 10 plus 15, that is minus 5, minus 6 plus 9, that is minus 3, and minus 12, 18, that is minus 6. So adjoint A into B is not equal to 0. It means that the system of linear equation is inconsistent, that is we can't find the value of x, y, and z here. Okay. Right. So question number 6, again same thing. Examine the consistency of the system of equations. Same method. I'll not repeat the things again and again. Do it by yourself. If you are not getting the answer, pause this video and then recheck. It is a consistent equation. Now we have learned how to check consistency and inconsistency of the system of linear equation. In the next video, we'll see how to find the values of x and y